So now that we've got the t statistic, the next thing we have to do is to calculate the critical value. What is the critical value? This is the value that the t should be greater than or lesser than to reject the null hypothesis. So let's write this down. Critical value. So now the formula for this is equal to t dot inv. Okay, t dot inv. We use the t dot inv two-tail if we are looking for whether the alternative hypothesis is greater than or lesser than 25. Okay, so just that the mean has changed from 25. So in this case, we're just looking in one direction, that is less than 25. So we're going to use the plain old t dot inv. Okay, so let's open the parenthesis and then it tells you probability and degrees of freedom. Okay, so the probability is how confident we want to be of our result. So let's assume we want to be 95% sure. Okay, this is a standard and hypothesis test. So when the probability is not given, you take it as 95. Okay, so let's write in 0.95, which is 95%. And the degrees of freedom is the sample size minus 1. Okay, so 1 less than the sample size. So in this case, the sample size is 44. Okay, so 1 less than sample size is 43, and that's what the degrees of freedom is. Right, so this is our critical value. So now we get the critical value of 1.68. Okay, so our critical value is greater than our t statistic. So therefore, we fail to reject the null. Okay, what does this mean? This means that because our t didn't go up to 1.68, we don't have enough proof that our mean response time is lower than 25. Okay, so let's look at this particular slide here. Okay, so here is the mean 25. Okay, and here we are here at one standard error below the mean. Okay, to get a 95% probability, we should have been at 1.68 below the mean. Okay, that means if we had gotten something like 2 standard errors below the mean, so let's say 6 minutes below, if our mean response time was 19 minutes, then we could have said, yes, we've lowered our response time. However, since our mean response time is 21 minutes, it's not far enough below the mean for a sample size of 44 to say that we've reduced our response time. So answer here is that we don't have any proof from this sample of 44 that the mean is less than 25.